So, what we've been looking over these past few weeks is triangles using sine, cosine, and tangent, yes? And we learned this week a sine of 47 degrees, sine of these angles gives us a specific value, yes? And we talked about it the other day. We can take sine of an angle, and it'll take something from an angle and give us a length. Yeah, which is kind of nice because we can solve for missing sides using that. Now, it'd be nice if we could go the other direction, wouldn't it? If we could take a length measure or a length setup and get an angle back. Yes? Now, there are units and there's methods that we can do this by. Does anybody have an idea what it is? What can we use? Because we have them on the calculator, because what is written right above sine, the sine button? You all see that there? It's in green. It looks like sine, doesn't it? Sine, and then it has to the -1. This here is called sine inverse. And there's also one for cosine, and there's one for tangent, because you can see it on sine, cosine, and tangent. It's written in little green letters. Sine inverse. And that's what we say that little -1 as, is an inverse. So this is sine inverse. Now, these are kind of the first four that you have. Try typing sine inverse of sine of 74. So to get sine inverse, we have to hit second sine, and then we can hit sine of 74. And type that in the calculator, see what you get. 74. It's almost like what? Sine inverse and sine kind of undid each other, yes? How about cosine inverse of cosine of 21.5? If we type this in, we would get 21.5. What about tangent inverse of tangent of 58? Give me 58. That's really nice, isn't it? Makes that really easy. Well, let's do one more. Let's do sine inverse of sine of, I don't know, 91. What does that give us? So let's plug it in. Just make sure, because it's 91. I'll go on and write it down, because that's what it's going to be. And what do we get? Huh? So it wasn't 91, we got 89? And that's it. That is true. Sine inverse of sine well, I'm not going to explicitly say it yet. That was kind of weird, wasn't it? It didn't come out to be the same. It's close, isn't it? Well, let's try it again. Let's see if, what would sine inverse of sine, let's just go up one, 92 be? It's like it's hovering around one number, isn't it? I'm going to go back. Let's try sine inverse of sine of 90 and see what that gives us. It gives us exactly 90, isn't it? So if I go above 90, it's like it's almost going back down, isn't it? And there's a reason for this. And the real reason for this is that sine inverse of sine of our angle equals the angle if and only if and only if, well, it's actually -90 is less than or equal to theta is less than or equal to 90. It works out that they undo each other and we get the exact same angle. if and only if it's between negative 90 and 90. So will we come across this case with what we're doing? Because the sum of the interior angles is always what? 180. And these here, what we're working for them, are only work if the triangle is what? A right triangle. So will any of the angles we kind of look for or find or have be greater than 90 degrees? Will those angles be greater than 90? Well, no, because any three angles in a triangle add up to be 180. Well, if one of them is 90, the other two cannot be what? 90. They can't be greater than 90, so we won't come across this. So we don't have to worry about this because our angle will not be greater than 90. Now, we do have to be careful if we come across a triangle that's not right and we use sine, so we have to be careful there. But the same thing is true for cosine. Now, cosine inverse of cosine of theta, so if this is true, so if we do 91 degrees, we'll get something different, right? Because we saw it with sine, yes? So let's try this. Let's see what happens with this here. What would this give us? Well, 91, wait. But it didn't work with sine. Oh, that's right, because it works out that cosine inverse of cosine of theta equals theta if and only if 0 is less than or equal to theta is less than or equal to 180. So for us to get the numbers where they're different, we would have to actually look at an angle greater than 180. Well, we're definitely not going to come across a case where that happens because the triangle is only between 0 and 180. So these here are some of the more intricate details of why this works. And they don't normally bring this up, especially in a geometry class, of that, hey, this works. They say, because what we did, oh, it works nicely, and then we kind of move on. But there are some restrictions to how it works. And there are methods that we can use to actually make up for that. We can adjust for that. But we're not going to delve too deeply into that. That's in one of the other classes, which you can take, where we get into more of this. But for now, we're going to use these inverses. And these tangent inverse and sine inverse and cosine inverse. Because what they will do is that they will take a length measurement, a ratio of the sides, and turn it into an angle. So before, with sine, cosine, and tangent, it took an angle and gave us a proportion or ratio of the sides. Their inverses will take the ratio of the sides and give us an angle. So it will go the other direction, which is quite nice. Because what that means is that we can look at these here. So we have tangent of A and these listed out. And I mean, if you don't have that written down, that's fine, because the main thing is our inverses. Now, when we looked at tangent, sine, and cosine the other day, we found that if I had sine of 45 degrees, it gave me it as a fraction. I could find the angle as a fraction and as a decimal, yes, for the side lengths. So what we're really looking at this here is sine, or tangent of A equals 0.75. So the opposite over the adjacent came out to be 0.75. Well, if I want to know the angle that it is, we can use these inverses. There's tangent of A. Well, I can take tangent inverse of tangent of A. Bless you. And tangent inverse of 0.75, because we know that tangent inverse of tangent of A what we're going to be using this for, will undo each other. They will cancel each other out and leave us with just angle A. But on the other side, I have this tangent inverse of 0.75, because what I do to one thing, I have to do to the other. And the reason we're doing this is because if I'm wanting to find that angle, well, tangent inverse of tangent of A, since they cancel each other out, since they undo each other, they undo that tangent function, it's the only way that we can get the angle out of tangent because they're stuck together. The only way that we can remove it is with its inverse. We can get the angle by itself. Now, if we take tangent inverse of 0.75, what do we get? Because we can plug that in. We can do second tangent 0.75, close that parenthesis. We get what? 36.8? 36.9 degrees. Because we want tangent inverse of 0.75. Because what it's doing is it's taking that opposite over adjacent, that ratio of the side lengths, and taking it back to the degree. So if you were to take that and type it in as tangent of 36.9 degrees and hit enter, you will get something that's close to 0.75 because we had to approximate the angle. It'll take you back to it. Questions on this here so far? Okay, well, let's look at the next one. Erase this here so I have a little more space. Now we have sine of B equals 0.87. And again, we were wanting to find the measure of angle B. Well, to get the angle out of sine, to get sine away, we need to use sine inverse. And we have to do it to both sides, because if I do it to one side, I have to do it to the other. And sine inverse of sine of B, these two will cancel each other out. They will undo each other, which will give us B by itself, which is equal to sine inverse of 0.87. Which will give me this angle measure. And that's the nice thing with these inverses, is that I can have side lengths, I can have these ratios of the sides, and sine inverse will undo it, getting us back to our angle. We can go back to what the angle was. All right, let's look at one last one. We have cosine C. This is the last one out of these three. 0.15. And again, if I want to undo this cosine, well, I'm going to have to take cosine inverse of it. Give myself much room. I'm just going to rewrite it. Cosine inverse of cosine of C equals cosine inverse of 0.15. We can take cosine inverse of both sides. And the reason we're doing this again is because cosine inverse of cosine of C, the cosine and cosine will simplify each other out, leaving me with C is equal to cosine inverse of 0.15. And last but not least, doing this here tells me that the angle C is and that's our angle. So if we typed in cosine of 81.4, it'll get us back to our 0.15. Questions on this here? Okay, so looking at the first one here, so we have three more we'll look at. What do I really need to do to find angle A for the first one? So what are we doing to find angle A? Tangent inverse, yes? Because I want to get rid of tangent, so I'm going to take tangent inverse of both sides, yes? Because tangent inverse of tangent leaves us with A, yes? Well, what I do to one side, I have to do to the other. Mm-hmm. So we're going to take this tangent inverse of 3.29. We take the tangent inverse of the ratio of those sides, and we get its angle. So questions on this here. How about the next one? What would we do if sine of b equals 0.55? All right, we're going to take sine inverse of both sides, which is nice because sine inverse of sine of b leaves us with our angle. Those undo each other. And if I type in sine inverse of 0.55 or 0.55 in the calculator, hit enter, it gives me an angle of 33.4, yes? And what about the last one? We're going to be using what? Cosine inverse. I know I'm writing this really small. So if I use cosine, I'm going to have to use cosine inverse to undo it. If I use sine, I'm having to use sine inverse to undo it. And if I use tangent, I'm going to have to take tangent inverse to undo it. Yes? Questions on these here? Any questions on anything we've done so far? Now, really, what are these measures here? These measures are what? The ratio of the side lengths as a decimal, yes? So that means I could use this probably to find actual missing side lengths. Okay? So let's actually try to solve one. Solve the right triangle, round your decimal answers to the nearest 10. Okay, so we do know it's a right triangle, so we can use sine, cosine, and tangent, because it has to be a right triangle to do that. What are we missing? We're missing the hypotenuse, yes. And what else? Because we have side lengths at 2 and 3, yes? But what else are we missing? Because we're missing something else. Huh? Do we have any angles? Well, we have the 90 degrees, yes? Do we have any others? Well, no. And 90 degrees really doesn't help us much at all for actually finding sine and cosine. Because, I mean, you have a calculator in front of you. What is sine of 90 degrees? Well, that's not helpful. Cosine of 90. What's tangent of 90? Undefined. So having 90 degrees, taking sine, cosine, or tangent of 90 degrees doesn't tell us anything. So we're going to need, if we're wanting to find a side length, well, we need to know the measures, yes? Angle measures. Is there any other way we could find the hypotenuse without using sine, cosine, or tangent? Yes. Pythagorean theorem always works on right triangles, yes? Why don't we use it? We'll find the angles in a minute. So we're trying to find the hypotenuse. Now we're told the values of the other two sides, which are? So we'd have 2 squared plus 3 squared. Now we could do this in a calculator because 2 squared, 3 squared are all on the same side of the equal sign. We can just add those together, yeah? So I can do 2 squared plus 3 squared in a calculator. Can you tell me the answer? Now 2 squared is 4 and 6 squared is, or 3 squared is 9. And 4 plus 9 is? Now what do I do to find the value of C? Right, we would square root it, because to undo a square, we square root it. And the square root of C squared would be C. And what's the square root of 13? I think the yellow calculator just says it's square root of 13, isn't it? It doesn't reduce. There's no perfect squares that are factors of 13. 13 is not a perfect square. So for our sake, we're going to leave it as the square root of 13, because that's as simplified as we can get. As simplified as it can get. Okay. So we have all three sides, and it was going to ask us to find all three sides. So any questions on side length before we move to angles, because we're going to have to find them both. Okay. So looking at the angles, we need to know them, yes? Now we're given all three sides, and we're going to need to find all three angles. Do we have a way that relates, or kind of a function that relates angles and side lengths together? I mean, yes, because we have what? Sine, cosine, and tangent, because sine of a given angle is equal to opposite over the hypotenuse. Cosine is adjacent over hypotenuse, and tangent is opposite over adjacent, yes? Okay. Which one do you want to use? Pick your poison. Tangent. So we'll take tangent of A or B? B. So we'll say tangent of B is equal to what over what? Opposite over the adjacent. The opposite side length is 2. The adjacent side length is 3. Yes? So what have I done so far? What have we done so far? We just picked the trig function to use because we do have opposite and adjacent, yes? Well, do we have opposite, adjacent, and the hypotenuse for either angle? Well, yes, we have all three sides, don't we? So does it matter which one we use to find an angle? Well, no, because we set it up like this here, yes? Tangent of our angle B would equal 2/3, yes? Well, it'd be nice to know what angle B is, because that's what the question's asking, isn't it? Is there a way that I can get B out of tangent? We can use what? Tangent inverse. Because tangent inverse of tangent of B, tangent inverse of tangent of B, what happens here? You're left with what? Angle B, yes, because tangent inverse and tangent cancel each other out. But what I do to one side, I have to do to the other. So I have to type in tangent inverse of 2/3. And we all agree with 33.7? Hey, that's really nice, because now since we have this setup, and we can do this here, we can find the value of an angle. So the value of this angle here is 33.7. Any questions on this here? Well, now we got to find the other angle, right? So what can we do to find the other angle? You have an idea? Right, we can use sine, cosine, or tangent. We can do it again, yes? Is there a different way than that? What would it be?
Add them all up.
from? Because any three angles in a triangle add together to be 180. There's nothing wrong with using sine, cosine, or tangent for angle A to find it, because it will find it. But we know any three angles in a triangle add together to be 180. So if I can do 90 plus 33.7, we can add these two together. That gives us 0.73. If we add them together, we get 123.7. And we can subtract that from 180. So we found angle B as 33.7. We found angle A as 56.3. And we found side length C as square root of 13. That's quite handy, isn't it? It's kind of nice. Because now I can start finding measures and angles using these nice functions. Questions on this here? Okay, what can we do first? Pythagorean theorem, it's nice, it's useful, it's handy. And it's a little right at times. Okay, so what would we plug in and what would we plug in where? Mm-hmm. 21 squared plus 20 squared equals c squared, because they gave us the two side lengths, they did not give us the hypotenuse. And again, at this point here, I don't expect you to memorize these out. But we can plug them into a calculator. 841, because 20 squared is 400, 21 squared would be 441. And we get this here. And lastly, we've got to take the square root of both sides to get c by itself. Nice even 29. That's nice. That's really nice. I like it when we get nice whole numbers. So, yeah. Pretty good. Well, since we got whole numbers, that makes this what? A Pythagorean triple. Because anytime we have three whole numbers, it is a Pythagorean triple. Okay? So we're good with finding the three side lengths. So what can we do to find one of the angles? Well, we're going to find both of them. So could I use sine of angle D? Do we have the opposite in the hypotenuse? How about cosine? Do we have adjacent in the hypotenuse? Well, yes. How about tangent? We have all three side lengths, yes? So we could find angle D or angle E using sine, cosine, or tangent. We just have to pick our poison. So what do we want to do? Cosine. Let's use cosine this time. So cosine of, let's do it, angle D is equal to what over what? Adjacent, which is 20, and hypotenuse is 29. I don't know why I about said 29 was the adjacent side. But 20 is the adjacent side. It's the one next to angle D. And 29 is the hypotenuse. So what would we do next? We do cosine inverse of both sides. Yes. So we'd have cosine inverse of cosine of angle D. Well, what we do to one side, we have to do to the other. Cosine inverse of 20 over 29. Well, cosine inverse of cosine of angle D would just give us angle D is equal to 46. Okay, since it's 0.46, if we want the nearest tenth, that would take it from 0.4.
46.
Oh, thank you. I think I need a hearing test. 46.4. Yes. Sweet. I need to get my ears checked or cleaned out, one of the two. So we get this here because we took cosine inverse of 20 over 29. We didn't get whatever I thought it was, or what I thought I heard. So we get this here. Now at this point here, we can do what? We can add 46.4 to 90 and subtract it from 180, yes? I'm going to give myself a little bit of space. If we add it to 90, we get 136.4. And if we subtract it from 180, so we found the measured angle D as 46.4. We found the measure of angle E as 43.6. And our missing side length, we'll call little f, is equal to 29. Any questions on these here? Any questions on any of these here? How we set any of these up? What do we think about these here? You kind of like these? Be ready for another one. Yes? Well, they changed it a little bit on us, didn't they? Because what's different about this one? You know what? Right, we're given the hypotenuse, yes? So we're solving for one of the side lengths and then finding the angles. Can I find the angles and then find the side lengths? I could, but that would restrict me on what I use, yes? Because if we look at angle H, could I use sine to find angle H as it sits right now? Why not? I don't have the opposite side from that angle, so I can't use sine to find the angle because I need the opposite side, yes? So it'd be easier if we had all three, wouldn't it? Because if I have all three side lengths, does it matter which one I use? No. So it's kind of nice having all three sides because then we can use whichever trigonometric function we want. Okay, so how can I find the other side length? Well, I think you all already know. Pythagorean's theorem, yes? So how would I plug it in this time? Right, 91 squared plus v squared equals 109. So at this point, we can't just plug everything into the calculator because, well, unfortunately, the numbers aren't next to each other anymore. We have to do 91 squared. Might need a little more space because 91 squared, I have a feeling, is big. Thinking 9,000? Huh? You're good? 8,281. This one's going to be even bigger. So what is 109 squared? 81. 11,881. So what do we need to do to get b squared by itself? Minus 8,281 from both sides, which will give us b squared by itself. That tells b squared is equal to 0, 0, 6, 3,600. Okay. Bless you. It would be 60. So our other side length is 60. So that gives us another Pythagorean triple. Okay. Any questions over any of this so far? We're good with this here. We're liking this at least as much as y'all have liked math so far. Well, take sine of g. I'm going to pick sine because let's just round it out. We've done one with tangent. We've done one with cosine. I didn't want to have sine feel left out. So we'll use this one now. So sine of angle G would be opposite over the hypotenuse. Our opposite side length would be what? Opposite side length to 91? Almost. I did? Yeah. Where is my head at? Man, it's almost feeling like it's a Friday. Yeah, almost. All right, so opposite angle G would be 91. Almost, I gave you the answer to that. So, and then the hypotenuse would be our 109. So we need 91 over 109. Now to undo sine, we have to take sine inverse of our sine of angle G is equal to, well, we got to do it to the other side. 1 over 109. And nicely, sine inverse of sine of angle G would just be angle G. Huh? Okay, thank you. So sine inverse of 91 over 109 would be what? 86.6? 56. Damn. 56.6 degrees would be our angle. Huh? And our other angle would be angle H, yes? And to find angle H, we would add it to 90 and subtract it from 180, which would give us
You take
56 plus 90 and subtract that from 180. Yeah, that would be 90, yes. And this is what we get here. Oh, it's big H, yes. So big H, now what they do with this here, the way they letter it, is always going to be the same. Angles are capital letters. Now the side opposite that angle is the lowercase version of that letter. So angle H would be our angle. The side opposite it, which is the one we found, we would denote as little h. And that's how they do most triangles. Is they'll set up the angles as capitals, so A, B, C normally, and the sine lengths are going to be little a, little b, and little c, and they respectively go together. A is opposite A, B is opposite B, and C is opposite C. And if you notice, that's how these are set up also.